Tor pluggable transports and obfuscation of traffic. If you are stuck behind a firewall or other such device, such as the one here on the diagram that blocks ports, you may need to use relays that are open on ports 80 and 443, or whatever ports are allowed by that device that is blocking you. Usually port 80 and 443 are allowed, as that is web traffic. And if you want to configure your Tor browser to go through a special port to get through that blocking device, you need to go here, Tor network settings. Then we want to go to this computer goes through a firewall that only allows connections to certain ports, and then you want to specify the ports here and click OK. There are less relays that run on specific ports, so you may have trouble with your network connection if you specify some strange or unusual port, but 80 and 443 should be okay, but it may be slower. Another way that Tor is blocked is through Deep Packet Inspection, or DPI, and Active Network Analysis. This is because it's possible to identify ordinary Tor traffic based on byte patterns that appear in it. DPI is probably Tor's greatest nemesis for blocking Tor. In fact, DPI is the best defense for anyone trying to stop traffic that they don't want. A number of countries are using Deep Packet Inspection, DPI, to classify internet traffic flows by protocol. For example, in 2011, the Great Firewall of China developed the ability to actively detect Tor. Tor uses bridge relays to get around a sensor that blocks known relays' IP addresses, but a sensor that uses Deep Packet Inspection to recognize and filter Tor traffic flows can, if they see the traffic, the Tor traffic, block the connection. Standard Tor bridges don't solve this problem. But something called pluggable transports attempt to mitigate the blocking of Tor through Deep Packet Inspection. Pluggable transports transform the Tor traffic flow between the client and the bridge. If you see here, this is what ordinary Tor traffic looks like. This is what Tor traffic looks like when it's been put through a pluggable transport. In this case, it's the OBS2 pluggable transport, and this is the OBS3 pluggable transport. The traffic signature or fingerprint is changed from the ordinary Tor traffic to something else based on the pluggable transport. This way, sensors who monitor traffic between the client and the bridge will see innocent looking transformed traffic instead of the actual Tor traffic. External programs can talk to Tor clients and Tor bridges using the Pluggable Transport API to make it easier to build interoperable programs. And here are some of the pluggable transports: the OBS proxy, Flash proxy, FTE, Scramble Suite, Meek, OBS4. Some transports try to make the traffic look like another protocol, and others try to make it look random. And some transports are aimed at evading IP-based blocks rather than content-based blocks. So these pluggable transports sounds cool. How do we configure our browser to use pluggable transports? Here, Tor network settings, then select My Internet Service Provider ISP blocks connections to the Tor network, then select Connect with Provided Bridges, and there you have your different pluggable transports. The pluggable transport must be supported by the bridge or relays that you connect to. No one transport will solve the problem. The transports need to be variable and evolve as detection evolves. They need to look plausible, but extra scrutiny by a sensor will likely reveal what it is. but the idea is to get past the initial scrutiny. You could set a pluggable transport up on your own bridge, and for example, if we look here, we've got Meek Amazon, Meek Google. If you were to use that, this would look like you are connecting to Google and/or Azure and/or Amazon. The idea here is that the sensor will find it hard to block the IP address that's associated with Amazon and Amazon services, because obviously this is used by that company and it will be used for non-Tor use as well, which means wholesale blocking of those IP addresses could be a problem for the user community that the sensor is serving. What you can see here is ordinary Tor, and this is a hex dump of the first thing that a client sends to its entry node. It's a TLS client hello message, as the outer layer of the Tor protocol is in fact TLS. Here you can see the cipher suite list in blue, the server name in green, and the TLS extensions in this brownie color. This is a decode from Wireshark. This does not look the same as, say, Firefox or Chrome connecting to a website via HTTPS using TLS, which is why Deep Packet Inspection can tell you are using Tor, or it's one method by which Deep Packet Inspection can tell that you are using Tor. And here on the left we can see a client hello using the pluggable transport Meek, and on the right we can see a client hello of Chrome 33 on Mac OS X. Meek is trying to pretend to look the same, or at least similar enough so that DPI doesn't flag it as being a problem. But as we can see, one of the big differences is that Chrome is supporting 20 cipher suites and Meek only 13. So it's these sort of differences that somebody using DPI, and even with pluggable transports, with closer examination, they can tell that something is amiss. It is an OPSEC principle to be uninteresting, and using anonymous bridges with a pluggable transport could make you uninteresting until the traffic is analysed. Then you become more interesting. If getting caught for using Tor has serious consequences, Tor bridges and pluggable transports are not recommended. They are only short-term workarounds, and any adversary of sophistication will identify that you are using them if they start to pay closer examination to the traffic, as I have illustrated. Other options to bypass Tor being blocked, which might be safer, include tunneling Tor through other privacy and anonymity services, as I've already said, like VPNs, nested VPNs, SSH, assuming they are allowed or they are viable where you are, or using off-site locations or potentially mobile communication, all of which we discuss in its own section.